Hello, and welcome to the 12th video in the C++ for Beginners series. In this video, we'll be looking at using pointers in C++. So let's get started. First, I want to start off talking a bit about memory addressing. We have briefly touched on the subject in earlier videos, but as you recall, every variable and object within our programs is stored in memory. We access these variables or objects by referencing the memory address of the item. So let's take a look at an easy example. For the most part, up until now, we have been declaring variables simply as x equals 10. It's been understood when we speak of x, or the value of x, we mean the current value inside the x variable, which right now is 10. More accurately, we can say that we want the current value stored at the memory location that we set aside and named x. When I do a simple cout to display x's contents, we get as expected a 10 on the screen. But x also has another attribute, its memory address. We can see the memory address of x by adding the ampersand symbol. In this usage of the ampersand symbol, you can think of it as meaning the address of, or get me the address of something. In this example, we want to return the address of x. And running the program again, now we can see we get the address of x. Note that if you follow along and run this on your own system, you will most likely get a different memory address, as your computer allocates and assigns the memory for you behind the scenes. But the point is the same. The variable x occupies some memory location within your computer. Depending on its data type, it will occupy a different amount of space. Remember back to video 3, we created a little data types display program. You can see that the characters, ints, doubles all require a different amount of memory space to be set aside to hold them. Over on the right, I have a small slide showing an example. I've declared two variables, I an integer and d a double. They each hold a value and each have a memory address associated with them. Let me go ahead and create a couple more variables. For now, we won't worry too much about the values assigned to each of the variables, as we should be pretty comfortable with how that works by this point. Just let me print out the memory addresses of each variable. So you will get different addresses on your own screen, but if you look closely, you can see that for the most part, the variable addresses will occupy sequential locations in memory. We can see that the doubles are spaced 8 bytes apart, and we can see that the integers are spaced 4 bytes apart. Note that the computer handles memory operations behind the scenes, so your results may vary, but these results are pretty typical. Before moving on, I want to also mention that the ampersand symbol can take on a slightly different meaning when it is used in the declaration of a variable. In this next example, I'm creating a variable named xref. It could be named anything, but I want to indicate we're going to reference the x variable. We do this by using the ampersand symbol between the data type and the variable's name, as shown here. I'm then assigning it the x's address. So this is basically an alias of x. I can reference the value stored at x's memory location either by using the x as we have traditionally done, or now by using the x reference. So used in this fashion, we're saying that this variable x reference does not get assigned the value of x, but instead it is assigned to use the same memory location as x. So do keep this in mind that depending on where it is used, the ampersand symbol can take on different meanings. If I go ahead and add two output statements to display both x reference's address and the value inside x reference, we can indeed see that it points to the same address as x. And of course, it should return the same value that we assigned to x. And now I want to move on and talk about the dereference symbol, also known as the asterisk. Up till now, we've used asterisk symbol mainly when we're doing mathematical operations, such as multiply 8 by 7. However, the asterisk can also be used to denote the variable as being a pointer to an object or variable. So if we want to create a pointer object, first we need the pointer's base data type. So if I want to make a pointer to integer x, we need to make the pointer the same base data type as x. Then I'm going to use the asterisk symbol to denote that this is actually a pointer and not just a variable. Then I'll just give it a name. In this case, I'm just going to call it PTR for pointer. And we're going to assign it a value. In this case, we want to assign it the value of x, or the address of x. Not the value, but the address of x. So again, since x is an integer, we're going to want to create our base type of our pointer integer. We can use the dereference symbol to indicate that we're making a pointer. Give it a name. We're going to assign it the address of x. Now if I add an output statement and run the program, we can see that indeed the pointer is pointing to the address of x. Now we can also dereference the pointer. So basically right now the pointer is holding the address, but if we want to dereference the pointer, we use the asterisk symbol in front of it, much like we did the x reference above. In this way, we're going to actually access the value that pointer points to. So the pointer actually holds the address of x right now. That's its value. But if we want to actually access the value that the pointer is pointing to, we use the asterisk symbol to dereference it. So now let's go ahead and compile and run. As before, we can see that it points to the value of x, which is 10. So let me get rid of a bit of this code to make it a little bit easier to follow. Okay, we've gotten rid of a lot of the excess code. I've just kept the two variables x and y. And I've also added some more description to the output, so it's a little bit easier to keep track of which value belongs to what. Okay, so we're just going to start off with, again, printing out the values of x and y. We're going to create a pointer, PTR, type int. We're going to assign it the value of x, just as we did before. Now print out both the address and the value that PTR is pointing to. And we can also change pointer. So unlike when we used the ampersand symbol to create an alias in the previous example, pointers we can actually point and move around to point to different addresses. So in this case, we're going to start off pointing to x, print out a couple of statements, then we're going to change where the pointer is pointing to the address of y. Then again, we'll print out two statements to demonstrate this. So let's go ahead and compile and run. Here we can see our results. So again, the address of x and y. Initially we were assigning pointer to point to x, so it matches up with the x address above. And it's got x's value, which is 10. Then we change the value of pointer to point to address y. We can see that indeed it has changed to now match the address of y. And if we dereference it, we can also see that it points to the value of 5, which of course we assigned y above. I went ahead and added a slide to the right to kind of demonstrate this visually. So in this example, I'm creating a pointer p that's pointing to the address of variable a. We can see variable a off to the right. It's got a value of 88 with an address ending in E8. Now there's also a variable b with a value of 111 with the address ending in E4. So currently our pointer p is pointing to a's address. As you can see, the value inside p matches the address of variable a. Then if we go ahead and reassign p to point to the address of b instead, we can now see that the variable p actually contains the address of variable b as shown in the bottom right. Before I finish up the video, I want to quickly cover pointer arithmetic. As you can see on the screen, I have a slide in the upper right. That's just an array example from our previous video. Here I just simply have a 5-element array with index 0, 1, 2, 3, 4, and assign it some values. Also have a representation of the addressing of it. And notice, since they're integers, each address of each element is going to go up by 4 bytes. Then we use a for statement to print it out. We get the output as shown on the right. Now I've just kind of copied that code on the left here within code blocks. So let me go ahead, compile and run to show the results. Much like the graphic, we get some addresses showing. I went ahead and created that example just so I can demonstrate pointer arithmetic. So I went ahead and created a pointer. Again, base type int, since the elements within the array are integers. Using the asterisk symbol to indicate that this is going to be a pointer. Naming it PTR, short for pointer. I'm going to assign it the address of our array 1 at index 0. Then below that I have a couple of output statements. The first one's just going to show the address of array index 0. And the second one's going to show the value inside. So let's go ahead and run that. And here we can see that indeed our pointer points to element 0 of the array just as above. And also points to the value of 11 as we can see up in the little graphic. Okay, so I've gone ahead and added a couple more lines of code. In this case, I want to show that if we increment the value of pointer using the plus plus, but notice in this case, instead of incrementing by 1 that we do like in our loops or other statements, we're going to actually increment by the value of the base type of the pointer. In this case, since it's an integer, as you recall, takes up 4 bytes of memory space. So when we perform this operation, we're going to actually increment the pointer address by 4 bytes. So let's go ahead and compile and run the code. Move down so you can see. And here, as you can see, the first time we ran it through, we pointed to the array index 0. Now, after incrementing the pointer, you can now see in the second one that we're actually pointing to element 1 and also returning the value within element 1, as you can see above in the graph. Okay, I've gone ahead and just added the remaining code so we can display the entire array. Again, each time I'm just simply incrementing the pointer by 4 bytes. And I've just added output to indicate where we are within the array. Let's go ahead and compile and run the program again. Here we have our entire output. So as you can see, the first time around, address of element 0, address of element 1, 2, 3, and so on. And we also got our values 11, 4, 18, 92, and 66. So this example, I just basically wanted to show you how we can use pointer arithmetic. We can also do the same thing, like if we wanted to decrement it, work pretty much the same way. It's just going to move down 4 bytes in memory. Okay, and to basically summarize what we went over in this video, first off, we can make a reference, like in this example. Here I've created a reference named myReference. We do that by using the ampersand symbol. It's a type of integer, and we're just referencing the variable x. And again, this creates an alias of x. It's pointing to x's address, which is why we use the ampersand symbol. But this reference is static and cannot be changed later on in the code. We can also use the ampersand symbol in statements outside of declarations. And in this case, it means the address of something. So let's return the address of something. In this output statement, we're going to actually return or print out the address of x, not the value in x, but instead the address of x. So just keep in mind that outside of declarations, the ampersand usually means the address of, give me the address of something. And we also looked at asterisk symbols to create a pointer. In this case, for creating a pointer of base type int, using the asterisk symbol to indicate that this is a pointer variable and not the normal variable. Pointer variables hold addresses. In this case, we're assigning it the address of x. Then again, outside of declarations, the asterisk symbol is used to dereference. So in this case, we're dereferencing the value pointer. So instead of returning the address, like if I just did standard cout PTR without the asterisk symbol, it's just going to print the address of X. But by dereferencing it, it's going to actually print out the value held within the address that it is pointing to. Okay, so that's a basic look at pointers. We'll be going over pointers more in future videos. But for right now, I just want to keep this somewhat short to kind of give you the core concepts of using pointers and the ampersand symbol to address various addresses. So I think that's all for this video. So until then, I'll see you in the next video.